Okay. Thanks very much for being here, and thank you also very much for attending our panel. And as Sophie said, this is a panel about preservation and how everyone can see computer games became a huge and very important culture. And I'm coming from the Computer Game Museum in Berlin, and we are working to spread the word about the importance of computer games. And of course, if you are aware about this importance, there's a second question which comes to one mind, and this is the questions about how computer games and how this culture can be preserved. And as you probably know, there are a lot of people working on this issue since many years, and so I'm very happy that Roberto Fresca is joining this panel. He's a member of the MAME developer group, and MAME is one of the most important emulators, as you know. And we have some second or another panelist here. This is Vincent Joguin. He's coming from France, and he's one of the initiators of the Keep European Research Project, which I want to introduce to you, because this is something additional, which something very important happening, that now the achievements and the results and the tools which are programmed and implemented by people like Roberto and many others for a lot of obsolete old platforms that enable us to play games without having the historic computers anymore, that these tools somehow will be enabled to be available also for future generations. And this is very much what this European research project named KEEP is about, and we will also give you an introduction into this. So you can expect this, and you also can expect an inside view of one of the most important emulator projects, MAME. So let me start first with a short introduction of the Computer Game Museum. Maybe you've heard about it, maybe not. So right now we don't have a permanent exhibition. We hope that we will have it again in the future. But I just told Vincent that when we opened our first permanent exhibition in '97, and it was the world's first exhibition about computer game culture, we had an article in Microbiti. This is one of the sponsors here. And since then, we had a lot of Finnish visitors in Berlin back these years from '97 to 2000. When we closed our permanent exhibition in 2000, we did a lot of exhibition projects. The best thing is you have a look at our homepage. It's there noted. And since then, we collected. And meanwhile, we have 16,000 titles in our collection. We have almost every home computer and console in our collection, which is released in in Europe. And we have a few arcades, but because they are so big, we have not that much. And we have over 30 exhibition projects. Meanwhile, it's only a small sample you can see here. And we are meanwhile member in a lot of, or in some networks and other associations, which you can here see also. But I show you this only very briefly because this panel is not about the Computer Game Museum, just to give you an idea who we are. And the Computer Game Museum is also partner of the KEEP project, and this is why I'm here today. I want to start to give you an idea what the digital revolution means for memory institutions. This is something really new for memory institutions, and this is a very simple picture I show you here, but it shows one of the main differences. Before information and cultural artifacts are stored digitally, you usually was able to see the information and to understand the information just seeing it with your eyes. But going digital means that you now see the information, it's still there, you can have a look on a CD under a microscope, and you see the bit stream, which is out of zeros and ones, but you need a complex apparatus of computer and operating system to encrypt this stream of zeros and ones. And so, as you can see, the very same stream, bit stream, can have very different meaning. And a human is not able to interpret this bit stream anymore, so we depend on this complex apparatus. And this is new, and this is new for every institution which is a memory institution. And so the problem is that this apparatus will not last forever. So we expect that a common platform like the C64 will only last for 40 years. And let's say that the last C64 is produced 93. Then we can expect that the last one which will work in future will be out of order 93 plus 40 years. So that means 2033, somehow one can expect that the last C64 which works will be out of order. And so if we want to preserve the culture of computer games and of course all other digital artifacts, we have to make it hardware independent. And this is when emulators come into play. And I don't think I have to explain to you how emulators work. So somehow they recreate what used to be in hardware in software. And that's what MAME is. That was others very important emulators are about. And just to give you a short idea of success, emulators, of the success of emulators, I show you here a graph of the MAME development history, and this shows you how many different arcade machines are meanwhile included in MAME. And so we are over 7,000 meanwhile, and Roberto just told me that this, of course, is not the most recent one. What is the number?
8,000. 8,300 approximately.
Okay, so more than 8,000 arcade machines, which are very different technically, are now can now be operated by MAME without having the original hardware in place. And so this development started in the mid-90s, and this was very much, of course, related to the establishment of the World Wide Web, because most of these emulator projects are web projects, are open projects, and the emulators, the programmers, the developers are working all over the world, and so Roberto is Argentinian, and so it doesn't matter because on the web that this was the platform. Everyone comes together and started projects like MAME. I want to give you but there are two problems, of course, at least two problems also with the emulator strategy. And the first one is a legal one, because to run a game on an emulator, I have to transfer it from the original media and make an image file out of it. I can run on the emulator. And this transfer is necessary because otherwise, if the program would be left on the original media carrier, then it will become obsolete and it will become not working anymore because, let's say, magnetic storage is only lasting for a few years. And so I have to transfer it, and this transfer usually is forbidden because there are copyright protection mechanisms on games, and so usually this is not allowed to circumvent this copyright protection mechanism. But I want to point you at an exception on the Digital Millennium Copyright Act, what is the copyright law for the USA. And this exception was granted on an application of the Internet Archive. And so since October 28, 2003, at least the archives in the USA are allowed to circumvent copyright protection mechanism if it is an obsolete media and if it is just for preservational purposes. So that means, of course, they are not allowed to offer that image file to the public for free, but they are allowed to preserve their own collection, what they own legally, on a legal way. And so this is something very important which happened there in the USA, and hopefully this will happen also to the European Union. We are working on it. And I want to point you to another difficult, and now I'm coming very much to the main purpose of KEEP. And this is that also emulators are a piece of software which have to be preserved. What does that mean? So this is how an emulator usually works, or how the structure is. So we have a current hardware operating system combination. It's, let's say, Windows XP. It's not Windows XP. I know it's a little bit an older diagram here. And then we have an emulator running on top of Windows XP, emulating original hardware, let's say some arcade machine, and then you can run the Donkey Kong code, in that example, the Donkey Kong code, as original on a platform which this code is not written for. And we have a lot of other obsolete platforms, meanwhile, like Amiga and dozens of others, and we have all emulators for these platforms provided from people who programmed this by passion, like Roberto and others who really just make it for free and offer it to the public, and we can use it. And we have ports for these emulators for a lot of other, for the existing operating system like Linux or Macintosh as well. But now it happens that Windows XP also becomes an obsolete platform, what happened already, as you know. And we have future operating system. And now we have three opportunities. The first opportunity is that, of course, the emulators are ported to these future platforms. And this is what happened since the mid-90s. Of course, the first MAME was for DOS, and then Windows XP or Windows 95 appeared. And the people who programmed MAME originally ported it to these new platforms. And they will do so until they are alive, of course. But the question is, what then? Because now they do it by passion, but we cannot expect that people in the future generations have the same relationship to these old platforms like the people which have programmed the recent emulators. There's another possibility. You build towers of emulators. Of course, you can emulate Windows XP on this future operating system, and this is what happens, because if you buy Windows 7, there's an XP emulator integrated in the compatibility mode of Windows 7. Is XP compatibility mode is of course an emulator, and then you can run MAME on it, on this emulation environment, and this tower of emulators will become bigger and bigger, higher and higher, and more instable. So this is nothing you can trust on. And now there's the third possibility, and this is somehow the idea of KEEP, of this European research project. It's programming a virtual machine, and of course then, every of these existing emulators has to be ported once on top of this virtual machine. But then you have a big gain. You gain portability, and you only have to port the virtual machine to the future operating systems, and all these emulators sitting on top of the virtual machine must not be touched anymore. So this is the basic idea, and this is what we try to realize with KEEP, and KEEP is an acronym standing for Keeping Emulation Environments Portable. And so this is why we come together, because we are KEEP is very interested in starting this dialogue with emulation maintainers. And yeah, so this is the idea I want to introduce to you. I think we can skip this, maybe just a short note that the project is running, just has started in February this year and will run until January 2012. And here I give you a brief overview about the partners of KEEP. And this is also very interesting, because we have 3 national European libraries as partners. And this means that for the first time, emulation as a preserving strategy is on the table of very established memory institutions. And so this is also a milestone, I think, in the history of emulation, because what grew in the retro gamer community and became popular there now is noted by established memory institutions, and hopefully we will be able to join forces just to keep that gaming culture and also the demo culture alive for future generations. And now I will pass the word over to Vincent, who is also a member somehow of the demo scene, and will give you some examples why this is all important for what we see here, there, in the arena. So, Vincent, okay. Please go on.
Thank you. All right. So here's my presentation. So I'm Vincent Joguin from France. My company is also a partner. What I should present, what would be relevant or interesting to such an audience. And after all, I thought, okay, it's a demo party, so maybe relationships and interactions between the topics of emulation and preservation on one side and the demo scene on the other side. Well, quickly, just some personal background. So I'm interested in computers full-time. I started slightly before, since 1988. Almost always been on the PC, so it was not a very nice PC at the time. I'm interested in the scene since '92. I organized some small parties in France in '98 to 2000. And since '95, I've developed some emulators which are not really well known. I started with Amiga, but then went to Atari ST, creating an emulator for DOS, which is called Fast, and a PC Junior 21000 emulator called Tandem. I'm also the author of Disk2FDI, which is a floppy disk imaging software that maybe some of you know, which is able to read Amiga, Commodore 6. Relationships between the emulation scene and demo scene. I believe personally that they share the same spirit, basically doing cool things that are commonly considered as impossible. Usually people will come and say, oh, well, we see in both worlds hoax, like, I did that, but it's actually a fake. And then people say, okay, but that could be possible, and they take the challenge and they try to do it in both worlds. They also share some people, just naming two here, like Tony Whelan from Win UAE, of course, and Leonardo Oxygen, who's the author of Saint. I've worked with him in some parts of Saint, by the way. So the scene itself is using emulation, mostly, of course, for older platforms. So for non-PC demo development, like C64 usually, using an emulator when creating a demo, of course, provides better debugging possibilities because you have total control over the machine. And you can use better tools, of course. You can use Photoshop and then just, for example, convert a very nice picture into IFly on the C64. It looks nice, but it was usually created on the PC. Of course, using an emulator for the users, let's say, or the watchers, brings a larger audience than just releasing a C64 demo on a 5-inch disc, which not many people have anymore. And of course, there is a third interesting side, which is, of course, the demo will be better preserved over time because it can be made available on the internet and run on modern computers. The scene actually also helped, in the past at least, improving emulators. We've seen like competitions between emucoders and sceners. One example that I'm going to show right now is the Deus Ex Machina C64 demo, which was released at the Mecha Symposium in 2000. And at one point, when changing disks, it actually detects or tries to detect if it's running inside an emulator. And at the time, emulators were not able to, well, they didn't emulate everything, well, what this is detecting. So of course it displayed you are not running a real C64, and you should use a real C64. I tried to find an emulator old enough to show you this today. And I spent quite some time in the process, but I was not able to find any because I think these emulators are so old that they actually only run under DOS. And because I just have an XP machine here, obviously, I was not able to run such an emulator. So I was only able to find an emulator which actually behaves like the real C64. So here's an example with Hoax. We are here at about half the demo when it's asking to turn disks, so I changed to the second side of the disk, and it's charging some more, and you will see. I can even put sound. That's a statement. And we are using, of course, a real C64. So I don't know, we can watch it maybe later. A little bit, all right. It's only the second part, of course. So it's an 8-bit machine from 82. For those that wouldn't know, it's very limited processor at 1 megahertz. Some nice graphics capabilities, but still limited hardware sprites, mostly, but many constraints in terms of color. For example, on the C64, you cannot actually refresh the whole video frame buffer in one frame. The processor is not able to just move the data. So usually when you see something very fluid like that, it's usually a mix of sprites and tricks of any sort. This is full screen, and of course it's not normally possible to do that. Of course it's better on a real C64. Here you have, it's normal that it flickers, but it should be fluid, and video synchronization with emulators is a difficult part, of course. When you have pauses like that, it's usually because it's either trying to read from floppy or pre-calculate a number of effects. Probably around the end now. Yeah, that's the end scroller. Okay. So let's just do that and get back to the presentation. Okay, so the point was that once again, it shows that there is spirit of challenge in both worlds. Sinners will say, "Oh, we are able to detect this is an emulator," and emulation authors will say, "Okay, we'll fix our emulators, and now it's correct." So it improves emulators in the end, and everyone wins, I think. And of course, I think all emulators since at least 2001 display "Thank you for using a real C64," which is a bit interesting. So it motivates emu coders to improve the accuracy of their emu. There can be also demo-specific features, such as, well, it's better known in France, actually. Some Atari ST demos reprogram the intelligent keyboard, the subsystem of the Atari ST, which has a programmable processor. For some reason, I'm not sure why Atari chose that. But there was, at one point, an article which was released in a French magazine, which explained in detail how to program this secondary processor, the 6301. And some French demo sceners went to actually program it, usually to display full screen, lots of tricks, etc., which were completely cycle exact, and they couldn't really afford to have a keyboard interrupt or any interrupt actually coming from outside. So they reprogrammed the keyboard processor so that they could check if a key was pressed, but exactly when they wanted in the demo. So it means that you have, in this case, to provide an emulator for this whole subsystem, which is almost a computer in itself. Just because of these features, if you want to render them, and of course it's better to preserve the original demos. So that's another example. the scene can also demonstrate the value of computer heritage. The cases where you would say, okay, this is worthwhile to actually preserve all these old platforms, which some might consider obsolete, not so great, that PCs are much better or whatever. But I think many people would believe that these so-called obsolete platforms really convey a different spirit, a different approach to programming, to computing, even under emulation. So they can sometimes provide more motivation and inspiration to code or to design things than current platforms. And one, I think, very good example of that is a demo which was released here at the Assembly 2006, and which won the competition against old PC demos. So it's an Amiga demo called Starstruck by the Black Lotus. And it's pretty nice indeed, and okay, I'll show it as well under WinUAE right now. It's all configured normally. I'm just booting the Amiga right now, so okay, it works. So probably some of you have seen it back in the day or since then. You can find a YouTube version of the demo if you want to see it easily. It was even captured at the assembly itself, so you can have a sense of how it was well received at the time. So that's an older version of WinUAE, so it worked at the time on it, so no need to, it shouldn't break anything. So that's basically the way it was actually presented at the assembly under WinUAE, but it was an Amiga demo. At the beginning, there is an interesting scene that you will see. Old computers, an old PC over here, and it's just old computers trashed in a future world and left over. I think it shows the importance of preservation here. So I think we'll just watch it, so enjoy. It lasts about 6 minutes, not too long.
exist in the universe, that all other life forms are inferior and must be exterminated.
Amiga. Two things here are a bug in the party version. So it's just, I think it's just brilliant design, excellent code. It's just what the Amiga has always been. So now we're back to PC. In a way, you could argue it's a PC demo because it was presented on a PC and works on PC. But still, it's a different thing, and it shows that these older computers conveyed a different feeling in a way. So they are worth preserving and worth passing on to future generations. Okay, so I think that's my last point here. Preservation in the demo scene. That's an interesting topic as well, because the scene may be, I think, possibly, I'm not sure, but the most active community in self-preservation. The scene is actually preserving itself very well. And it's not really the case with the games, for example. Unfortunately, the games, even the developers are more sensitive to it, but the publishers usually do not really care about preservation. In a scene, we've seen very early with Hornet.org, the older will remember. It was a US-based site which started preserving and offering demos on the internet. And it was, of course, followed by Scene.org and another one is C64.ch. And other examples like Mind Candy, the Mind Candy DVDs, and other DVDs. So the scene itself is looking at what it's doing and trying to preserve that, offering this to everyone for future generations, etc. So it's a very good example of a good practice, let's say. Sorry, okay. Not from my computer. So the future for us, so we have a virtual machine under development within Keep. This virtual machine, which Andreas introduced, can be programmed in assembler, in a specific assembler, an assembler for this virtual machine and C. We hope to have GCC ported to, retargeted to this virtual machine. The first test program that we made together with my colleague is a rotozoomer. It's some kind of demo. We definitely hope to stay in touch with the scene and all. We might, well, it's just an idea that maybe some demos could actually be created on this virtual machine, and it could be also a platform for demo development. So we'll see how it develops. So thank you very much for your attention, and you can find my email address in the lower right corner. So if you have any question or any you just want to get in touch or anything, feel free to email me. No problem. Thank you very much. I think I'll pass the floor to Roberto, who is back more to games. You don't need a computer, I think.
No,
Okay.
absolutely. Absolutely not.
Try to stop the sound. Where's the sound? Oh, there's still a sound here.
Are you okay?
Okay, maybe it's.
Okay, my name is Roberto Fresca, and I am joined the main dev team since 1998. We passed a long years programming emulations, you know, trying to preserving the old arcade games. Maybe most of you have no idea what I'm talking about, and I think MAME doesn't need any presentation, and most of you know really what it is. MAME stands for Multiplayer Arcade Machine Emulator. It's just a piece of software that is trying to reproduce in some way the original arcade games. That games that you used to play when kids, maybe. Just put some coins and just start to play. Well, okay. To go further about this, I need to fully explain the differences between emulation and simulation. Well, a simulation is just a port of. If you have a given game, just suppose, I don't know, Galaga or another one, Donkey Kong, another classic that you already know, just a simulation is a port of this game for another platform, completely different platform. It means that maybe a group of programmers just wrote a new program from the scratch that made exactly the same thing, the same behavior of the original game, just for another completely different computer. To take the point, I can give some examples like the Shinobi version for Commodore 64 or another one, wherever one, I know, maybe the Pac-Man one for PC. There are ports. They are written from the scratch. And this kind of, okay, it's okay. This is simulation in itself. Graphics and sound could be ported as well. And sometimes it depends on the target machine, the capabilities of the hardware in the target machine. You can find that maybe sounds and graphics are better or worse. It depends on several things, well, okay. You got the point. So we can see about emulation. What's the big difference here? Emulation is a very complex task here. Why? Because there are plenty of arcade systems over there. There are all systems, very complex systems over there, and you can see that are composed for at least one or more PC boards, that are electronic boards full of components there. And in the components, you can see maybe one or more CPUs to run the program. And you can find as well some RAM memory for another side, sound devices, maybe lot of sound devices, not just one, to reproduce different kind of sounds there. The former ones has a kind of discrete circuitry, no sound chips, so the task is very more complex in this way. Also, you can find video chips over there, just to put on the screen the things. Actually, maybe CRT controllers or another kind of devices. Well, okay. Each board could be different functions, and you have the system. This is the hardware part of. So, what about emulation? The emulation task is to reproduce in software each one of the components, internal components, CPU, sound devices, and whatever, and creating a virtual board, a virtual environment there, where the original program, I mean the original game, thinks really that it's running in a physical board, in a physical environment, but not. It's running in something virtual. The game itself has no idea, but it's running and it's working. Emulator allow you to see the results there. It's very complex, this task, but anyway, I will try to explain a bit more about how I discovered the emulation and why I'm so enthusiastic about this. Emulation allows you to preserve the original games and the original things, just in case of computers, like my partner said about, you have the original programs for the computers and several jewels over there that maybe are in risk just because of the magnetic degradation, optical degradation, or whatever. In case of arcade machines, the normal programs and graphics and so on are stored in real chips that after 20, 25 years or so, they suffer some kind of degradation. It's called bit rot. And some bits are rotten inside, and so a lot of classical games could be lost forever. So, well, I discovered emulation in an accidental way, believe me. It was half of the 95, and the World Wide Web was not so common, or at least it was not so usual for common people like me, even living so far. And so at this time, there were a lot of magazines that came with a CD attached, full of shareware. Now you say, oh, it's a crap, okay. But for this time, at 96, this CD is like gold. It's full of programs and you can see everything inside. So I just watched the CD, I start to browse the CD, and in the game folder, I found Time Pilot. And I said, oh, come on, I know really this game. It's an original Konami game, and it's a classic. So I gave it a try. And so I put in my powerful computer 486 DX100. You can say, okay, I run the game. The game start, the attract start, and say, oh, come on, these graphics are looking so original. Nice try. And then, suddenly, it happened. What? The sentence, insert coin, start to blink. Okay, I am shake the same way as they used to see that, really. It's a trick from the programmers just to keep the people happy. But something inside me was telling me that no, there is a trick here. There is no trick here. It looks like the original one. Could it be possible this? So I started programming in assembly language for Commodore 64 and early 80. So I had an idea about the hardware. I knew about the hardware, and so maybe it's possible. I was very curious, so I was inside the folders, and I discovered the original programs inside. So it's a fact. this piece of software are running the original program inside another completely different environment. Okay, so I understand that this is a milestone. Because, why? Because really, you are finding a way to run an old environment inside a new one. And what's the limit here? Oh, come on, they're not. You can get a powerful computer to run an emulation. You can run one computer inside another one, and maybe inside another one, and so on. Not now due to the capabilities of the current machines, but maybe, and in further, you can have several degrees, several, how can I say, several steps of emulation, emulation from emulation from emulation, and then you can run all the old software that will be preserved for the further generations easily. Okay, at the beginning, sounds a bit utopic to do that, but you can say MAME itself. Just start with a couple of games and a lot of dreams. Now it reproduces more than 8,300 games. So it is possible, believe me. In fact, it's fantastic that you can have a way to reproduce another machine inside another one or whatever. Just before I leave my country to join here for the Congress, it happened something very important on MAME. It's the first time that MAME will emulate MAME itself. You say, how? Let me explain a bit. There is a board over there that is ARM-powered. It means that it has a CPU, ARM type, that is running MAME itself and are emulating 39 games. The board is to connect in a machine. You have the PC board, you can play the games there, the 39 games there, and it's powered by MAME. A version, obviously, is not coming for us. It's a bootleg board, a pirate board, but it's running for MAME. It has MAME emulating games inside. Well, for the first time, we have an emulation of another emulation that is emulating games. MAME is emulating MAME that is emulating 39 games too. I know, maybe I'm a bit enthusiastic to see the further about all things. I think any system, any old system should be preserved because it's our patrimony, it's our cultural patrimony. So we need to fight so close and join efforts to avoid this material can be lost forever. You know, okay, I have nothing more to say, and thanks a lot for hearing all things. And I need to say thanks to Andreas Lange that he made a special invitation for me to come and join the panel. Thanks a lot. Have a nice day.
Hello? Okay, now it's open. Okay, so now the floor is open for questions and comments, please.
So what do you think is going to be the future of emulation? Because when you see there's more and more complex systems like the PS3, and when you look at even older systems like the Xbox, for example, hasn't been emulated properly yet. So as systems grow more and more complex and more difficult for a casual programmer, bedroom, programmer, someone like that, to spend time and to try to emulate a system, what do you think the problematic will be, or how do you see emulation orienting itself? Do you think it's going to be for older systems and preventing bit rot and things like that, or it is going to be a valid issue for the future also?
Well, hi, check. Let me explain a bit. When a system is becoming more and more complex, as you say, there are plenty of obviously complex, more complex systems there. The problem there is the bottleneck about the current computers today. Normally, the emulation is CPU power, nothing more than CPU power. So you must calculate between 30 or 50 times. If you are emulating a processor that is maybe, I don't know, 100 megahertz or so, you need to raise by 30 or 50 times the power you need to emulate the system. But it's not the only thing here. You need to calculate the complexity about the system. And various systems are very obfuscated by hardware and has some encryptions and several things that don't allow you to just, we'll go to make this kind of emulation and so, no. To make emulation is a very complex task for several things. Normally you have several things well documented there, but usually for intellectual properties or for some secrets, you have no idea what is inside this system. So there is too much reverse engineering involved there. The main goal of the emulator, at least for MAME, is not to be so powerful to run in a decent rate any game or any system. It's just to be accurate for one side, to reproduce exactly the same that the original hardware. And another one is for preservation. Preservation and documentation of the old things regarding. When you develop a driver, you are documenting the thing how. Normally are kind of guesswork, but you can see several technical things that I can annoy you with this, just to see, follow a flow about the program and see this CPU, what is making here, is writing here, is waiting for some information, and you need to figure out the things. As soon as the system became more complex, you need to understand the protections, obfuscations, encryption, and several things. You have not currently a system that can emulate in a decent rate this very, very, very complex systems. But one day, yes, absolutely. I don't know if I'm not clear enough. It's okay? Okay.
Yeah, maybe just to add, maybe
Other
it's not
question?
working. Oh, it's working. Maybe just to add to Roberto's comment right now. Yeah, of course, I'm on the same side that we will probably have to emulate even the more modern, complex systems eventually. And this is getting it's becoming a bigger task, of course, but it's more challenges before it. Maybe now it looks a challenge, but before emulating an Amiga, for example, sounded like a challenge, like I explained. So I think it will be the case. But there are maybe bigger challenges today with preservation of, let's say, the digital world. It's not really complexity of systems, but the way the digital world now is connected, networked. And if you look at the preservation of the internet, it's quite a big challenge nowadays because it is complex. It's a different kind of complexity. It's not really hardware, but lots of links and technologies. And there's a big question out there is, do we want all this to disappear, to just fade away? And I think it's a problem, and especially national libraries, other people. Of course, the answer is no, we can't. We have to do something. And it's very difficult because there are many different technologies. Some resources are hidden behind passwords or things like that, restricted, or and of course it changes very frequently depending on the browsers, etc. So this is maybe the next challenge, probably in emulation, being able to preserve the web. But even then, some people are trying to do it. So yeah, probably anything digital, the best strategy, at least we think here, is to go with emulation, with trying to actually, yes, run the original code as much as possible to preserve the original material, yeah.
Here's another question.
I'm not sure, but when I think of preserving current digital entertainment systems like Xbox 360 and PS3 and Nintendo Wii, it's not because of the internet connectivity and all the DRM technologies. This is and the current trend from the publishers, because I think that I am seeing. I'm just a consumer. I'm not any kind of industry insider, of course. But I am seeing the tendency that publishers they have a strong economic interest in making all this content disappear after a certain time, and they will use technological barriers to make the solutions harder. So I'm not sure about if it's a question, but I think it's not only a technological problem. Mm-hmm. It should be addressed in some kind of political way too.
Thank you very much for that comment. That is very very true what you said. That of course this very recent internet-based digital copyright protections are a big challenge for future preservation, and this is why I pointed at that it's now important that what grew in the gamer community and what is developed in the gamer community is now somehow picked up by established memory institutions, and if this going further and if we coming closer together, then I think we will establish a platform which somehow enables us to advance the law and to make it possible to preserve this internet-based copyright-protected games together with the publisher, because the preservation movement is becoming more powerful. The more established institutions join this movement, which started all about in the mid-90s from out the gamer community.
Yeah. Okay.
Oh, good.
Okay, go ahead.
No, I just wanted to add, you mentioned it briefly, but I think maybe indeed the answer is on the side of the law. Because if publishers indeed want to put restrictions that they can validly put for commercial reasons, on the other hand, the national laws and European law can probably protect the preservation efforts from the preservation community to allow, technically speaking, what is necessary to preserve all this material. So right now the law is too old. It will probably have to be renewed. Within our project, we are conducting, actually one side of the project is to review the existing law and to see how these technologies of emulation, etc., can be indeed applied to copyrighted material. And most probably it is still under review, but most probably one of the outcomes of this study will be that the laws will have to be improved and updated to take into account all this, so that some institutions, not everyone of course, because otherwise the interests of the publishers would not be respected, but some national bodies will be able to actually, legally speaking, to actually access the material necessary to preserve all these things which are currently very important there, and it's a very big industry, of course.
Maybe just another comment to add. So one of the reasons why KEEP happened is that the National Library of France is commissioned by law not only to collect games which are published in France, but only to preserve them. And so there's a legal commission to preserve games. And so this is one reason why Keep happens.
Yeah, and this includes PlayStation 3, Xbox 360, all the new things. So they have quite a challenge here, and it's a national constraint. They have to do it in one way or the other. Yeah.
Yeah, hi. Are the original game and hardware developers usually willing to help you in the preservation work?
Sorry.
So he asked if there are hardware developers and publishers who helped you in the past, for example, developing MAME. That's the same question I asked.
There are people developing.
Yeah, if you get support from the industry. Have you got support from the industry?
No, being honest, not. It's a bit complex because even when you are trying to emulate games or platforms, maybe we have a rule from years. If a game is old, we can emulate. We can't obfuscate the companies trying to emulate something that is selling currently, you know. And so we have time to emulate the games. Even when we are emulating old, very old games, it's publicity for the company too. But anyway, the companies don't allow normally. They say nothing about, but have no support about this. Normally, except a couple of exceptions, like Gaelco did with us. I will explain this one. The rest, no, normally hide a lot of documentation on things, and just obfuscate our work because you need to reverse engineer a lot of things to figure out how the hardware is working. Some companies like Gaelco give a big hand to us. They explain how some protection things work for the World Rally, and even they are offering the ROMs for the main people, for any user that can, I don't know, want to play the game without non-profit purposes, you know. But there are few cases like this. The normal is not.
Yeah, and I can add that there are some other signs which might make us hope that the support will be better. So one partner of the Keep project is the EGDF. This is the European Games Developer Federation, and they are partners of Keep. And so in May, we had a panel at the Nordic Games Conference in Malmö, a Keep panel, something very similar than here, approaching the games developers and introducing Keep to them and asking what their needs are and what they think about. And so it started, hopefully.
One more question.
Yeah, I got one question. What do you think of efforts now that we see from bigger companies on commercial emulation? For example, what you see on Xbox Live, on Virtual Console, on the PlayStation Store, and even GameTap has emulation nowadays. Do you see that as a good thing that older games are being offered to a consumer nowadays, or do you see that as a bad thing that they're behind closed platforms?
For me or for you?
Maybe?
I know, it's okay, start. I will add things. No,
yeah,
start, please.
Well, I try to answer that. I think it's, I would say it's a different use of emulation. I don't believe it's really, they really have a preservation approach. It's more like these games have a commercial interest, so fortunately it's a good thing they are offering them again through emulation. I think what it shows is that preserving these games, really preserving them, not, well, offering them commercially, I think is not a way to really preserve them, but it shows that it's worthwhile to preserve them, that they have a value, these old games, which is something that sometimes when we look at the publishers, they tend, commercially wise, we could think that it's not worth anything. After 6 months, the next game is out, and the old ones, okay, they are just older, obsolete. So I think it's nice because it helps the cause of showing that it is worthwhile. It also shows that the emulation strategy, as something to recreate or to make older games live again is a good approach because it works at least commercially. But I'd say it's not really a preservation effort, and there's room for other initiatives.
No, it's okay. So
Okay.
yes, it's the same.
Thank you.
Yeah. Thank you for all our viewers, and also thank you to the panelists.
Thank you very much. Thank you.
Oh, I forgot maybe one more. So there are brochures of the key project, so if you are interested, take you one.